Today we will be discussing topic 3, the Pythagorean converse. In a previous lesson, we learned that how to determine if something is a triangle. We take the two smallest sides, we add them up, and they must be bigger than the third side. Today we're going to be determining if it is a right triangle. And in order to determine if it's a right triangle, we have to look to see if c squared equals a squared plus b squared holds true. So in this case, we have three sides of a triangle, 12, 16, and 20. 20 is the largest number there, so it would have to be the hypotenuse. So I'm going to plug it into the formula, and 20 squared equals 12 squared plus 16 squared. I don't know that, so that's a question. I'm checking it. So I plug it in, and I'm asking myself, is 400 the same as 144 plus 256? 400 equals 400, so this is a right triangle. Now down below, we've already said that if c squared equals a squared plus b squared, it would be a right triangle. We also have acute and obtuse triangles. In an acute triangle, acute is always less than 90. So if c squared is less than a squared plus b squared, it is an acute triangle. If c squared is greater than a squared plus b squared, then it is an obtuse triangle. Let's look at a couple of examples. In the first example, we see that we have 5 square root of 56 and 9. In order to understand which one would be the largest side, we have to know that the square root of 56 is approximately 7.48, making 9 my largest side. So if I look, I'm going to plug it in to c squared, a squared plus b squared. I'm still trying to figure out which side is bigger, so I just put a question mark there. 9 squared, is that equal, bigger, or less than square root of 56 squared plus 5 squared? Now when I square root of 56, I just get 56. And I can do that in my calculator. And when I add 56 and 25 together, I get 81. Since 81 is equal to 81, this is a right triangle. Looking at the second example, since all of these are under the square root, I can look and say, well, what's the biggest number under the square root? In this case, it's the square root of 6, because 6 is the largest number. So that would have to be my hypotenuse. I'm going to ask myself, which one is bigger, the left side or the right side? So I'm going to plug it in. When I square square roots, they are inverse operations and they cancel each other out. So I just get 6, 4 plus 5. I have to figure out if it's equal, less than, or greater than. 4 plus 5 is 9, and 6 is less than 9, which makes this an acute triangle. Finally, I have 7, 2, and 8. Looking at that, 8 is my largest number there. So I'm going to ask myself the same question. I'm going to plug the 8 in for the largest number, or my c, find those square numbers, add them together, and I can see that 64 is greater than 53, making it an obtuse triangle. Now let's look at one more example. I'm going to graph this triangle and find the lengths of the sides. Then I'm going to use the Pythagorean converse to classify it as right, acute, or obtuse. First, I need to graph those points and make a triangle. Those are my points. When I connect them, I can see my triangle. The next thing I'm going to do is pick 2 of those points and determine the length of that. So I'm going to pick E and F first. I would use my distance formula, but I do know that my geometry formula sheet gives me this really awesome circle equation. And if I use xy as one point and hk as another, I can find the length of the radius, which would also be the length of anything. So I plug in xy as one point and hk as another point. So when I plug it in, EF squared is equal to 2 minus 0 squared plus 4 minus 0 squared. I plug those in the parentheses first, 2 squared plus 4 squared, which is 4 plus 16, or 20. So I can take the square root of both sides. Now, for the sake of this problem, I'm going to leave it as a square root because the last thing that they're asking me is to really determine to find out if it's a right, acute, or obtuse triangle. And what we just did was we squared square roots, which cancels everything out. So instead of giving a decimal approximation, I'm just going to leave it as square root of 20. So let's look at the next side. The next side that I'm going to look at is EG. Now when I look at EG, I'm going to do the same process. I'm going to plug in the 2 points. I'm going to simplify, square those numbers, add them together, and take the square root, giving me the square root of 40 as EG. I have one more side I need to look at, and that would be the side FG. When I look at FG, I'm going to do the same thing, plug it in, simplify. When I square a negative number, I get a positive number. I add those together and take the square root, and I get FG is the square root of 20. Now that I have all 3 side lengths, I need to determine what kind of a triangle is it. Is it right, acute, or obtuse? What I do know is that 40 is the biggest number underneath the square root, so that would be my hypotenuse. When I plug that in, I'm asking myself, c squared, is it equal to, bigger than, or less than a squared plus b squared? I plug it in. When I square square root, all those square roots disappear. And what do I know? That 20 plus 20 is 40, and these two are equal, which makes it a right triangle.